In this video, I want to run through the final code for the Keypads 4017 Chaser encoder. This will be the code that's required to do the bench testing, and the final code for the final build when the Keypad 40 is connected to the Keypads 4017 Chaser encoder. I'm just going to run through what the code looks like when it's downloaded. We went through this before, but I just want to go through it again. We go through the Arduino folder. We got to find the project folder we want. This is the project folder we want, the Keypad 4017 Chaser 2.2a. And these are the three files that reside in that folder. This is the main code. These are the two function folders for the EEPROM and the PCF8574. And in the Arduino IDE, I already have the code downloaded, but you hit the File tab, do the open again, like we did before. Documents, Arduino. Search down till you find the Keypad 4017 Chaser 2.2a project folder. Open that up. Highlight the main code, the main file rather, and these two function files will attach itself when you download it or open it. And it should look like this when everything is downloaded into the Arduino IDE. There's one library in here. It's the wire.h. That's for the I2C bus. The EEPROM is defined as 0x50. And this keypad client address 9 is the address on the I2C bus for any clients that would be attached to the build, where you want to read the characters into another Arduino, LCD, or whatever other devices you want on the I2C bus for the keypad to interface with. This address can be changed here. This is the only place you would change it if you want a different address, and of course you'd have to have the same address in your client device. These are a bunch of variables that are declared. There's a bunch of integer variables, some byte variables for the different pins on the 4017, the shift button. There's some variables here for the PCF interrupt. You can go through them and get an understanding more on what each variable is for. I don't want to spend a lot of time going through each one. I don't think it's necessary. In the setup, we do the wire begin again, initialize the I2C bus, initialize the serial monitor, declare some pins as outputs and inputs. Okay, the clock and reset pin on the 4017, the shift button is an input, the PCF 8574 interrupt is an input, and so forth and so on. And these are some of the pin numbers on the Arduino, okay, that we're writing a low and a high to already initialize them as low or high before the program is actually ran in the main loop. In the void loop, this is where this for loop scans the columns 10 through 80 for the 8 columns. And down here is where if one of the keys are pressed, it's going to create an interrupt from the PCF 8574, and the Arduino will read that interrupt as a low. And when that's read as a low, before it leaves this main loop and goes to the function, it's going to read the shift button and store that high or low state into this button state variable. And then it's going to come down, it's going to jump to this function, the keypad PCF 8574 test function, which is here. Okay. In this code here, in this function, it's going to do a wire request from the PCF 8574, and it's going to request 1 byte. Okay. And if the wire is available on the I2C bus, it's going to take that byte of data that it reads from the PCF 8574 chip and store it in the PCF read byte variable. Okay, and it's going to end the transmission. Okay, this this code here, this is a reset code that resets the 8574 back to its normal state, if you will, because if you read the data sheet, you have to do a reset when one of the ports switch state from high to low. Otherwise you could create another interrupt, and I don't want to create any more false interrupts. Okay, this will do nothing in the program to execute anything. It just basically does a read on the 8574, and it will read all of the ports as high as long as no buttons are pushed on the keypad, and it will just reset everything, and the interrupt will go back to high, and then it'll just sit there and wait for another low on the one of the port pins. So that's all this basically this code does. If you would use a library for the PCF8574, which I'm not using, this is most likely built into the library, something of this nature, so that they can put a reset on that 8574. If you want more information on it, there's a write-up in the data sheet for the PCF8574 that explains it a little bit more. Okay. Alright, this is where it gets a little bit tricky. We're going to do a masking with a bitwise operators, because we have to figure out what row was actually pushed. Okay. And right here in this if statement, this is the byte of data that we read from the PCF8574, and this is the mask here that we're going to overlay over this byte of data to see which bits compare, so we can figure out what row was pushed on the keypad. Okay, I'm going to bring this little pop-up here. That's going to maybe help. These bitwise operators are really sometimes a little bit rough to understand, so I'm just going to go through it briefly. And there are some YouTube videos on it. There's a bunch of other literature on the internet on it, and I even had a little problem with it, so don't feel too bad if you don't understand it at first. What happens is this for loop, of course, every time it runs through this for loop, this 1 here will increment by 1. So right now it's here. The next run through the for loop, this will become a 1, and this will become a 0. Next run, this will become the 1, these two will be 0. You understand? It's just going to keep on incrementing through. Okay, as this for loop is being ran. Okay, and as it's being ran, it's going to come, every pass will look at this if statement, and this PCF read is the byte of data that was read from the PCF8574, and it's going to compare it to this mask. Okay, so in other words, the first run, the mask looks like this, with a 1 at the far right here. Alright, and it's going to compare it with the data byte that was read from the PCF8574. So if row 2 was pushed on the keypad, this bit here will be 0, because this is row 1, row 2, row 3, row 4, row 5. Okay, so the mask will overlay it over this byte of data here. Okay, and the way the bitwise operators work is, if we have a high and a high, because it's an AND type bit operator, if it's a 1 and a 1, the result will be a 1. If it's a 0 0, it's going to be a 0. If it's a 0 and 1, it'll be a 0. You get the idea. Okay, so if the result equals the mask, the else statement is not executed, because it's saying the PCF read and mask, so they're equal. So it's going to jump out of this if loop. It's not going to run this else statement, because this statement up here is true. So it'll run down here again, and it'll come up to the for loop, and it'll bump this 1 over to here. Okay, so this would be the next read. Okay, we have the same byte of data from the PCF8574. Now the mask, this 1 is over here. Okay, so now we have zeros. This is a 0 because you got 0 and 1, and these are all zeros. So the result is not equal to the mask, so now the else statement will be executed. Okay, alright, because this if statement is not true. So now it's going to jump and run the else statement. Alright, so that's where it gets this, where it's going to print out the column number. Okay, it's going to print the column. It's going to say what row it's reading. Okay, through the row num. Okay, and then the key address to find out what key was pushed. It's going to take that column. Okay, which column 2 would be 20 because the first column's 10, second column's 20. It's going to add it to the row number. Okay, and then it's going to subtract 1. Okay, so if the column is 20 and the row number is 2, if we added them up, that's 22. Well, the actual row number is 20, is going to be 21. Okay, because we go 20, 21, 22, 23, 24 for the 5 rows, so we subtract 1. So of course 22 minus 1 is 21, so we know it was key 21. So that's going to be our key address. That's the EEPROM address. It's strange, but you study a little bit, you'll see how I came up with this. Okay, and then it will just print the EEPROM address that it's going to be looking at. Okay, now then it's going to come down. Let me get rid of this here. Okay, and once it comes through the loop, then it's going to, once this else statement is being read, it's going to come down, because this else statement, if we go here, okay, this would be the else return. Alright, then it's going to come down and it's going to read this loop here. It's going to read the keypad EEPROM read. It's going to jump up to here. So we're going to read the EEPROM now. Okay, we do the wire begin. Okay, make sure our I2C bus is initialized, serial monitor. Now it's going to do a wire begin transmission of the EEPROM address. It's going to wire write down the key address we want, end transmission. It's going to do a wire request from the EEPROM of 1 byte, and if the wire is available, it's going to do the wire read from this address and store it in this ASCII value variable. Okay, alright, that's going to be the decimal value of the character that key is associated with. Alright, then it's going to come, it's going to end the transmission. Then it's going to check the state of the shift button. So if the shift button is pushed, if we're asking for an uppercase letter, if the button is high, okay, it's going to take the ASCII value of that character. And remember, we talked about we just subtract 32 from it, and that's going to give us the uppercase ASCII decimal value for that uppercase letter. So that's where that's where this is done at. It's a very simple code. It just subtracts 32 from whatever value was read from the EEPROM. Okay, then it takes that value and converts it to a key character. Okay, because this key character variable is declared as a character. Okay, so it will read the internal ASCII table on the Arduino IDE and come up with the character. Okay, this is the character requested, and it'll print that character. And then here is where it will send the keypad character via I2C bus to the keypad client. This is where it sends it out to that address 9 that we talked about earlier, transmitting to client. It's going to just print out transmitting to client. It's going to begin the transmission to address 9. That's the keypad client address. It's going to wire write the key character out on the I2C bus, end the transmission, and it's just going to print out that it sent that character to the client. And that's pretty much it. It's a little hard to understand. Like I said, I'm not using any libraries here. This is all code that I wrote. So study it and if everything goes good, you should have no problem with it. Alright, the next thing we're going to do is build the Keypad 40 keypad, and that'll be the final part of the build.